Science and medicine sometimes have an arrogance problem. They use the idea that trust us, we're the experts.
All across the United States, school buildings sit empty.
Unfortunately, that trust has to be won, not just assumed. Often, scientists are entrusted with policy decisions for which they have no specific expertise, or decisions about how to run things in society that they might claim expertise for, but they actually have no special expertise for. And those are the reasons why I think sometimes people develop mistrust in science.
In this episode, I sit down with Charles Piller, the investigative journalist for Science magazine, who is behind some of the biggest exposés on scientific fraud. His recent book, Doctored, has uncovered widespread corruption by self-interested researchers, government accomplices, and greedy corporations, all racing in the quest to cure Alzheimer's. We discuss secret data manipulations, shocking misconduct, and the unsettling truth about how money and prestige can derail real progress. But it's not all doom and gloom. We also dive into how we can rebuild trust and make science work better for everyone. So sit back, get comfortable, and let's jump right into this eye-opening conversation. I'm excited to speak with you because a passion of mine in the healthcare space is talking about trust in science, in medicine. When I have a patient sitting across from me, the most important thing that I think about is the doctor-patient alliance. How can we get onto the same page? Because without that level of trust, we technically have nothing. I'm basically a robot saying science words, and if they're not landing, they're not making an impact, I'm not helping. These days, I feel like there's been a tremendous loss of trust in our scientific institutions. A, have you seen that happen? And B, what do you think is leading the way for that to occur?
Well, I think it's tragic. Myself, as someone who tremendously supports scientific research and the wisdom of doctors, truly, it's been very sad to see the decline in public understanding of how important those processes are. I think it's due to a couple things. One is I think there are people in society who are using doctors and some of the medical situations we've been experiencing, such as the pandemic, to beat up on institutional authorities like in medicine and for political purposes. And I think that's horrible and unfounded, unwarranted. The second thing is that science and medicine sometimes have an arrogance problem. And they use the idea that trust us, we're the experts. And unfortunately, that trust has to be won, not just assumed. And when you have situations where there are missteps, honest human mistakes, or scandals associated with misconduct, or simply just bad moves, bad policy moves, what you see is that often scientists are entrusted with policy decisions for which they have no specific expertise, or decisions about how to run things in society that they might claim expertise for, but they actually have no special expertise for. And those are the reasons why I think sometimes people develop mistrust in science. Now, as for me, I'm deeply, deeply determined to try to fight off the needless skepticism, the needless complaints about problems in science and in medicine, but also to be serious about identifying problems where they are in order to strengthen the scientific infrastructure, if you would, to strengthen the ability of doctors to have those honest and effective conversations with patients.
So are you saying you seek to be critical of the scientific method, of the scientific agencies, in order to make it more valuable to the general public?
I would just change one word there. Not so much the scientific method, which I think in its highest form is a wonderful and well stated process of experimentation and testing hypotheses. That part of it is terrific. It's where people cut corners or ignore important elements of the equation where you start to run into trouble. And so, yes, I support the very excellent exercise of that method. And I support people who are trying their level best to deliver something important to the public, even if they do sometimes make mistakes.
How would you describe the scientific method for the general public?
Well, science is a series of iterations. And I think one of the great things about science is that every new discovery opens up vast new areas of ignorance in order to be able to explore and improve upon what we know. So I would say it's bringing in a hypothesis forward, testing it, and then learning from those tests what amount of that hypothesis was true and correct and can be applied to human benefit. Sometimes we see that these ideas are completely without foundation when they're tested, and those should be discarded. Others have a grain of truth or an element of them that could be extended and made into something very valuable. And every so often, there are tremendous breakthroughs that are discovered in a single series of experiments.
Why do you think that currently in our state of media, there's a lot of fanfare where there's a positive scientific research article, and yet when there is a negative finding where it negates something that we thought or perhaps something that we believed in at once, there is less fanfare about that, less correction or noise about the correction? Why do you think we don't focus on those as much?
Well, I think there's one fundamental problem in the scientific literature that leads a bit to this, which is that careers are made on discoveries. They're not made on repeating experiments and finding that they don't work after all.
Isn't that why we have the replication crisis that we currently do?
It is. And you see it in all different fields, not just, of course, in Alzheimer's disease, but in all different kinds of medicine and social sciences. And even
psychology a lot.
Absolutely. Yeah, it's a big problem.
And for those who don't know, the replication crisis is if we had a piece of research done in the 1950s, we try and replicate the same research with similar methods, we don't usually get the same results. And that's a problem because generally speaking, when we do a piece of research, we should be able to, using the same methods, get to the same results. Why do you think that we're not being able to replicate those studies? You think it's largely because of fraud, methodological errors, something else?
I think it has more to do with the incentive structure of science and how scientists build their careers. So often the paradigm publish or perish is extremely true in all different realms of science, in biomedical science, in physics, in sociology, whatever scientific field you're in. And that means creating a lot of papers. And one thing that we know from bitter experience is that people don't go back and say, this didn't look quite right. Well, this other scientist's work didn't look quite right. I'm going to check it out and do an experiment of my own that's similar or the same as this, because it's very difficult to get those published. Journals do not want replicated studies, especially if they're equivocal or if they disprove something, particularly if the original experiment showing something ostensibly important was done by a well-known or famous or perhaps just esteemed experimenter.
I can imagine if you're trying to grow your career and you're looking to have more citations, it's not helpful to do a replication study because odds are that it's not going to have a lot of citations. The original work might, but yours probably won't.
Odds are you're not even going to get it published.
Yeah. Do you think that creates a crisis for us where we're putting out new research that is hell-bent on creating a new discovery, but it's based on shaky science as we currently have it?
Well, let me say that I think that the vast majority of scientists are honest. They're trying their best to do something useful. They may feel the pressure of the field they're in and the competition and the incentive structures that may be misguided, but they're not dishonest. They're not cheating. They're not falsifying information. That said, there are many who are. Just like in every walk of life, you have people who are cutting corners or doing something illegal or dishonest. And so I would say that people can trust the vast majority of experimentation. I think what's not as well understood is that a few experiments or a relative few of experiments that are done improperly, that are based on false ideas or are deliberately doctored, deliberately changed in inappropriate ways to, say, support a hypothesis that can't be supported by the actual data in the experiment. when those things happen, they can skew thinking in the field. They can have subtle or sometimes very obvious effects in steering other scientists in certain directions, particularly if they're done by important people who have a lot of influence in the field, including some that I've written about.
Yeah. And how does that factor in when we look at our hierarchy of evidence and, expert opinion being low on that pyramid? And as you go higher to the meta-analyses, the systemic reviews, how does it factor in that there are perhaps studies that were done with poor data, falsified data? How does that impact our ability to do those high quality reviews?
Well, I think the reviews are only as good as the stuff that they're built on. So it's garbage in, garbage out, I'm afraid. And if studies are unreliable, they can have that ripple effect. Also, you see in many of the metadata studies and the reviews that you're referring to, even by some of the best review organizations like the Cochrane folks over in UK, those are done with extremely high standards, and they try to throw out data often that isn't really that reliable. The problem is, if data is falsified, it can be very difficult to know how reliable it is. And so therefore, you see over and over again that a lot of these review studies are equivocal in their conclusions. They don't come down firmly on one side or another. Is this treatment valuable or is it worthless? They often say, well, we can't really quite tell. And
the forest plots all over the place.
There we go. It's partly because you have not enough data. It's partly because sometimes you have poorly done studies or even falsified data that skews the overall thinking in the field and the ability to combine it for a concrete solution.
Where do paper mills fall into this equation?
Well, this is a phenomenon that is a pernicious effect on scientific research. So I mentioned before the publisher perish ethos within scientific careers. And because of the pressure that scientists feel and the competitive nature of the field, the too few jobs for too many PhDs, for example, what you have is a situation where clever entrepreneurs, if you want to call them that, have developed these companies where they generate fake papers. In other words, kind of interesting sounding, kind of plausible sounding scientific papers. And then they sell authorships to the papers. Sometimes these are generated even by AI programs. Wow. And they sell these authorships to people who are desperate enough or simply confused enough to pay a little money to get in on the game and be able to enhance their resume to get jobs or to increase their ability perhaps to have publications in legitimate journals.
So how do we fight back against this potential fraud that seems to be growing?
Yeah, so it's a great question, Mike, for a few reasons. And let me answer it in a couple different ways. So we are very privileged in this country to have excellent institutions that regulate, monitor science, the funders, the journals, the regulatory agencies like the Food and Drug Administration. These are agencies and groups that have, for many, many years, served the public well with advancing scientific ideas, but I think have fallen behind in critical ways, in ways that we need to press them to improve for the sake of the scientific record and also for the advancement of medicine in general. Let me give you the example of this is something that to me was a pretty stunning example from research that I did for the book that also appeared in Science magazine recently about the guy who used to be the chief neuroscientist in the head of the division of neuroscience at the National Institute on Aging. That is a very important agency that funds research into Alzheimer's and other neurological disorders. And when this guy was, I found in my reporting, had been apparently falsifying images and other data in his studies going back a quarter century. And
this is Dr. Maslia?
That's right. Very important guy in the business, very highly regarded. His studies had been cited by leading people in the field thousands and thousands of times, even though they were filled with images that appeared to have been based on doctoring in ways that often fundamentally changed the results so that you could no longer rely on the experiment, no longer rely on its conclusions. So when I asked the National Institutes of Health, which is the parent agency for NIA, when I asked them, did you, when he was hired, do any sort of check for possible falsification of data in his work? The answer was no, we didn't, and we don't think that's very useful or helpful to our agency. So to me, it was a stunning display of complacency, a stunning display of an attitude that is very much out of step with the realities of our current situation, where the technological means to alter images in a way that's very hard to detect has been increasing day by day. And I think it's going to get worse with AI. So we need to build up the infrastructure of people that are conscientiously thinking about these issues in advance, carefully, and with the idea in mind that while most scientists are honest and would never do this, there's enough of it out there to alter the field, and we need to take a close look.
I find it so strange that these organizations that put so much emphasis on making sure that they rule out conflicts of interest, that they disclose conflicts of interest, anything that could potentially influence an article's predisposition or ruling thereafter, are so nonchalant about potential fraud that can occur within the same ecosystem. Is that because they're more worried about the fraud coming out and them being implicated in it? Or is it they have blind trust in the people that they work with?
Well, I think it's a combination of factors. First of all, the regulators and the funders, they identify with the scientists who ask for their money and who are asking them to review and approve drugs. They identify with the companies and with the individual scientists at universities. These are their peers, these are their colleagues. And so they want to assume the best and also want to give them the benefit of the doubt. That's one thing. Second, I think they are technologically behind the times. They are living a little bit in the past. They haven't realized that the degree to which these problems have increased with the ease with which scientific images can be altered in a relatively seamless way. And it's pretty interesting. I think one of the things that to me is the most interesting about this entire state of affairs is that, like so many things on the internet, what has happened is that because when institutions don't effectively do their job, there becomes a community of people who are self-organized and they start to do the job for the institutions.
The sleuthing of the world.
That's right. The image sleuths, they like to call themselves often. And these are folks that in their own spare time, because almost no one's making a living doing this, they're just fascinated by the discovery process, like, a little bit like true crime detectives.
Mm-hmm.
And what they want to do is look at these images, interestingly, even without understanding the underlying science often, you can just become an expert in understanding whether images might have been altered and using software tools to assist that process. And so in a way, the image sleuths publishing on things like a website called PubPeer, which frames itself as a discussion club for articles, scholarly articles. And in fact, what often happens is that it becomes a place where people with concerns about possibly altered images or phony research can post those. And they usually are posted as questions. We're not sure what's going on here, but this doesn't look right to us. Can the authors please respond to this? And I think you'll find that about 90% of the time, there's no author response because they usually don't have a good story to tell, because these image sleuths many of them are quite good at what they do. And they're taking the place of institutional authorities like journals, funders, and regulators who are not doing as good a job at watchdogging these issues.
Do you think that there's a rise in this type of corruption in the scientific world because of the finances involved and how there's been an astronomical rise in the potential money to be made on medications, on discoveries, on breakthroughs? Is that the incentive there?
I do think it is in cases. Just to be clear again, I think the use of image manipulation to move forward drugs in development, it definitely occurs, but it's not common. There are lots of problems in drug development, as I'm sure many of the people viewing or listening to this really know from their own experience or from observing the news. But in this case, it can be used in that way. So let me give you an example. So something I write about a lot in the book is a company called Cassava Sciences, and they developed an Alzheimer's drug called Simufilm. So it's a funny generic sounding name. This drug was meant to be a cure for Alzheimer's, or at least a drug that could show dramatic improvement in cognitive symptoms, which would be an amazing breakthrough. So for the last several years, there have been a series of developments showing that, number one, the basic science studies, these are the studies that are before you get a drug into development. You have these, as you know, basic science studies that test things in the lab to see if the drug might be relatively safe and relatively effective in people. And then you go through a series of other studies, like these so-called phase 1 studies, where it's just testing for safety. You don't want to give someone a drug that might be very harmful, so you test it in a small number of healthy people to pass that bar. And then you go into phase 2 and phase 3 trials, which tested in much larger numbers of people for both safety and for effectiveness. So this is a company where for years, it's been shown over and over again that the basic science experiments associated with their drug were apparently based on doctored images. And this was known by the funders, by the FDA, and by the general public, because it was written about in the press by myself and many others. Then, more recently, it was learned that even the clinical experimental data was cherry-picked and changed in its presentation by people within Cassava Sciences, and to make it look like the drug was being more effective than it really was in its phase 2 studies. This proved to be instrumental in getting the FDA to permit it to go into phase 3 studies. But all along, the FDA, from its own inspectors, knew that there were problems with these data. They knew from press reports and from whistleblowers that there were problems in the basic science research, apparently altered images left and right, many, many examples of this, even questions about the fundamental scientific idea behind the drug and how it was learned. So you have that going on for years, and the FDA didn't step in and stop the trials. Ultimately, quite recently, the company collapsed because they finally had to admit that the phase 3 trials of their drug failed, and the value of the company shrunk by 85%, literally in one day. I might add that even after one of the important scientists involved with this company was indicted for fraud by the Department of Justice, the U.S. Department of Justice, this almost never happens. Even after that, even after the company was forced to pay $40 million in fines to the Securities and Exchange Commission, and even after 2 of the top officers of the company were ousted from their jobs and forbade from becoming officers or directors of companies for years, even after all this, the FDA didn't step in and say, oh, wait, we've got to do something about this. They just let the trial run its course. They let thousands of patients take this drug for a long time.
You have this company that's fraudulently taking, I forgot what, $16 million in NIH grants. Why is the FDA allowing that?
Let me frame the word fraud and what it means. It's a legal term that one has to use carefully because it has to be proven in court. But what I would say is that this company has been shown to engage in behavior that caused federal agencies to step in and really crack down on them in a dramatic way.
Mm-hmm. And why hasn't the FDA stopped the trials if that was going on?
I think there's a kind of complacency in certain ways in which the agency operates. And I think also that there is such a desperate hunger and a sense of real desperation in the community of patients and family members who are living with Alzheimer's to have some sort of drug, some sort of remedy that can at least allay some of the worst cognitive symptoms. And it's very, very hard for the agency to resist the pressure that they're feeling from drug companies, from patient representatives, from the entire world to try to come up with approved drugs that can be used to help solve this terrible problem that we have with Alzheimer's.
I also don't see how it's valuable to manipulate or create data in the basic sciences step, then do it with the phase 1 trials, when you know at some point the other shoe is going to drop and it would be found out that the medication is not as effective. Are scientists who engage in this type of behavior hoping that maybe getting past the first stage will get them ultimately where they can prove truly that their medicine or treatment works? Do they have true belief in themselves, or are they usually full on playing one of these games of let's make as much money as possible?
Yeah, it's tough. I mean, I'm not a psychologist and I don't play one on TV, so I can't really answer for sure what's going on in their minds. But what I can say is that you have a situation where historically it's been pretty easy to get away with falsifying data. And so there are many people who will roll the dice on it and reap the rewards. And so even in a situation like the one you're describing, again, going back to Cassava Sciences for a moment, what you have is a situation where there was apparent image doctoring going on from the very beginning, apparent flaws in the thinking of this entire process from beginning to end, apparent other kinds of improper activities at the company. But even though the drug finally failed, even though it's never going to reach market, even though the company cratered afterwards, over the course of those several years, many years really, that it was under development, the company officers, the scientists, and some of the scientists involved got very rich off of their optimistic appraisal of what might be possible for this drug and reaping the benefits in the stock market absorbance and acceptance and promotion of their drug. This is a example of something called a meme stock that perhaps some of the listeners are very familiar with, but funny things can happen in the market, and the behavior of a stock might be not that closely connected to the real possibilities for what their product is. But in this case, it was both a meme stock, but also the stock potential was enhanced by optimistic statements that had ultimately been shown to be based on incorrect data or falsified data.
You mentioned several times the image manipulation. What exactly are we talking about?
Okay. So let me give you an example that I think is quite common in biological sciences and in Alzheimer's disease in particular. You start out with images of brain tissue. So you want to examine what is going on inside the brain with, say, the effect of a particular drug, or how do you characterize an experiment's effects on brain tissue? And of course, with people, it's with Alzheimer's disease, these are usually samples from people who have died and have donated their body to science. But these images then may not necessarily show what you're trying to show to prove your hypothesis out. But by altering them, you can make the image look more in line with what your thinking is. Let me give you a sense of how I think it sometimes evolves in the thinking of a scientist. So a scientist might start out being completely straight up and honest and not interested in doing any sort of manipulation, and be very, very deeply in a sense
Committed
of,
to the science.
so committed in such a state of kind of rapture about their own ideas that they really would love to prove them out. And who among us can really step completely away from that?
Sure.
People become absorbed in their thinking and, want to be right. And especially with something for which so many people are hoping that they might be right about, say, a new drug or a new experiment. And so what you might have is a stepwise process where, first of all, what these scientists might be thinking is, well, I'm just going to make this image look a little bit better. I'm going to make it look prettier, and it'll have more curb appeal for journal editors who, like everyone else, are susceptible to looking at more perfect looking images, even in the scientific sense that maybe most lay people aren't going to know the difference between a better looking or worse looking slice of brain tissue imagery. But scientists know what they're looking for and what they're looking at. So you could say that maybe that isn't misconduct. It's maybe frowned upon, but it's something that can prove to be acceptable in the scientific process, or at least people get away with it so often, and it's kind of like a misdemeanor, you might say. Then they might think, well, I know that my experiment is correct, and there's a little bit of evidence for it in the scientific images that were generated, but it's not really crystal clear. I'm just going to sharpen it up a little bit. And they think, well, I'm only enhancing slightly what I know to be true. So that might be the next step of thinking. And then finally, what sometimes happens is that people say, well, I know that my experimental premise is correct. I know that my idea for this experiment is one that could bear fruit. But for some reason, I'm not getting quite the result I'm looking for. I'm just going to change the image in this way and in that way to show as if it were a correct result, because I want to be sure to get it accepted so that I can do further research in the field in this direction. And that is outright scientific misconduct. So I'm sure that this progression happens. It probably happens often because many people start out in science with only the best of intentions, with only the superior ethics, but then kind of fall off that path and begin to do things that I think most of us would agree is improper and misleading.
There's got to be a good name for that corruption cascade. There's got to be a nickname for it.
We need to get something we can trademark.
Yeah,
right?
exactly. Because I could see how that stepwise pattern could occur, especially with all of these publisher peril models that are going on in the scientific mind, especially of a young researcher. There's been some critics of the major governmental institutions, NIH, CDC, that they are not letting younger researchers take stabs at getting grants. Do you feel that to be the case, or that's not really happening?
Yeah, I mean, the competition in particular for, there's a kind of grant that the NIH gives called R01, and this is a potentially multi-year grant. It's very coveted because historically it's been used to launch a lot of early career scientists in their career. They have a good idea, they have a good set of ideas that could be developed, but they need time. They need to get a little traction in their laboratory work. And these are so competitive, incredibly hard to get. And often now you're seeing scientists waiting until their 40s to get these R01 grants that can kind of set them on their path. I think it's partly that the competition is a good thing because sometimes the best ideas rise to the top. Sometimes it's a terrible thing because a lot of great ideas get squeezed out of the system. And conventional wisdom can ascend and dominate and become sort of impossible to get away from for certain people. Let me give you an example of how that, I think, has had a deleterious effect on Alzheimer's disease. So some listeners might be familiar with something called the amyloid hypothesis. This is the dominant hypothesis within Alzheimer's disease. And to state it quite simply, it involves the idea that deposits of these amyloid proteins, which are sometimes called the sticky plaques that accumulate in a person's brain. They also occur in other forms that can dissolve in the fluid that surrounds your brain, that these amyloid proteins lead to a cascade of biochemical effects in your brain that ultimately result in dementia. And this idea has had such dominance, and since its ascendancy about 30 years ago, has literally crowded out a lot of other ideas because the funding has been so robust for the amyloid hypothesis that a lot of investigators feel that their best chance of success in the field, a field that they care deeply about and may have innovative ideas about, but they know they might have to hew as closely as they can to that hypothesis in order to be funded because of bias in the system associated with it. Now, I'm happy to report that it's not like all research in the field is strictly about that. There are new ideas coming to the fore that I think are innovative and interesting and are beginning to get funding. And of course, there's always people who are interested in exploring prevention associated with neurological disorders, including Alzheimer's, that merits a lot of attention and can have some success. So all of these things are happening simultaneously. But when you have one idea that has so deeply captured a lot of the scientific thinking in the field, it can crowd out things. I like to think of it a little bit as, if you want to use an analogy to why do farmers rotate crops? Because if you have a monoculture, one crop in the same field for year after year after year after year, it can exhaust the soil of nutrients that it needs. And so they rotate crops. I think there needs to be some rotation of ideas within Alzheimer's more than we see today in order to come to the full potential of innovation.
Mm-hmm. And within this research that you've investigated so thoroughly, has there been evidence that was supporting the amyloid model that has been disproven, or has it largely stayed out of that discussion?
Well, the genesis of my interest in this had to do with a famous experiment, one of the most influential experiments in Alzheimer's disease, basic science experiments. And this was done by scientists primarily at the University of Minnesota. And what this experiment did is that they extracted a certain type of amyloid protein from genetically engineered mice that were designed to produce a lot of amyloid protein in their brains. They extracted this protein, a certain specific type of amyloid protein that they called amyloid beta star 56. So this was, they even came up with that kind of clever name for it, AB star 56, that was very memorable. And then they injected it into rats, and the rats then showed signs of memory loss that could be compared to certain symptoms of Alzheimer's disease. So what was really interesting about this experiment was that it was a sort of proof of concept that amyloid proteins had a direct relationship to causing something like Alzheimer's, at least in rats. And so the initial article I did in this realm involved an assessment of that experiment and related work. And what was found by a particular scientist with whom I worked very closely and who produced a dossier, you might call it, on a lot of the experiments in this group, was that this experiment was based on thoroughly doctored images that had been changed in ways so as to support the experimental premise and results. And so what you have here is a fundamental experiment in Alzheimer's disease that had a lot of influence in pushing the field forward and validating the amyloid hypothesis and encouraging people to look at new elements and permutations of that hypothesis in a way that had tremendous, tremendous force in the field. What we found was that it was based on false data, on data that was proved to be false. And 2 years after my story in Science came out describing this, the paper was finally retracted by most of its authors. And it was appearing in the journal Nature, which is a very important, famous journal. So this was a kind of a landmark moment in a way. So to answer your question more broadly, in my book, Doctored, I looked at several dozen important scientists in Alzheimer's research and, of course, their collaborators and their trainees. So all in all, the work representing the work of hundreds of scientists in the field, including some very important scientists. And so thousands of images in these many hundreds of papers that were examined were found to have been based on improperly changed or doctored image manipulation. And what percentage of those were related to the amyloid hypothesis? The vast majority. And the reason is pretty clear. When the dominance of an idea is so extreme in an industry that most of the research is associated with, in one way or another, with the amyloid hypothesis, it's logical to understand that this would be found not just in good science, in strongly developed and reliable science, but also in doctored science or just plain poorly done experiments. And part of the reason for it is that it's easier to get away with improperly changed, manipulated images in Alzheimer's disease, if you're going for a set of ideas that is already well accepted in the field, there's less scrutiny. There are people who say, well, of course, this is a logical finding in this experiment because we know from this experiment and that experiment and these 50 other experiments that have done associated with the amyloid hypothesis that, of course, we're going to find something like this. And so people cut corners and they think, I'm never going to get caught on this. And maybe I even believe in it deeply and I'm willing to roll the dice on possibly getting caught. But there you have it. Yes.
These big journals, Nature, Lancet, there have been issues with journal articles being published that ended up being retracted. There's supposed to be a peer review process that is very thorough. And part of that peer review seems to leave out the fact checking of corruption, of fraud. Do we need to change the peer review process to make those people participating in peer review to be more cognizant or to be on the lookout for these type of situations?
Yeah, I want to tell you a small anecdote from one person who I looked into the work of, a very famous Alzheimer's and stroke scientist at the University of Southern California by the name of Berislav Zlakovich. And when I looked at dozens of his papers and people who were helping me with this and working on examining the images found, a lot of problems with these papers, a lot of apparently doctored images. Part of my due diligence process, part of my own process of checking the believability of concerns raised about these images is to go to subject matter experts in the field, people who know this stuff cold and would be able to both understand the possibility of manipulation, but also its meaningfulness, whether it's important or not, what it does to change ideas in the paper and in the field itself. And I'll never forget this moment where I went to this particular expert who was world-class expert in the science behind some of these papers, showed him the dossier, and he came back to me and he said he was sort of astonished himself because he found in the dossier of apparently doctored papers a paper that he had personally peer-reviewed and approved for publication. He had no idea. But in seeing it in the dossier where the image is taken apart and it's analyzed step by step what might have happened, he said, of course I should have seen this. But we're not asked to do that. We're not trained to do it. What we're trained to do is look at the science and see if it makes sense. We're not trained to look for possible fraud. We trust our colleagues. We trust their scientific expertise and their veracity as scientists. And so I would say, in answer to your question, should peer review change? The short answer is yes. People should all be somewhat on the lookout for this. It shouldn't be this obscure thing that people don't even think about when they're reviewing papers. But I think the primary responsibility should lie with the journals themselves. They need to put in place sophisticated and methodological procedures for checking papers, the same way they review papers to see if they are scientifically important enough to publish. They need to make sure that they're scientifically honest enough to publish. Fortunately, there's software tools that make a big difference in helping check for that nowadays. And so both using those tools and then having a human being review the results is a critical first step. Now, this can cost money. Journals don't want to spend the money, but look, if they're going to represent science properly, if they're going to prevent us being steered off into wrong directions and dead ends, it's essential that they start to get serious about this process.
Yeah, they put so much emphasis on impact factor. Maybe we should put a bigger emphasis on fraud factor.
There we go.
You mentioned that specifically within Alzheimer's research, there's been the issue with this fraud because of the initial basis for the amyloid hypothesis. Does that mean everything we know, or at least thought we knew about Alzheimer's, is actually fraught with major error and we need to go back to the drawing board? Because my initial education on the Alzheimer's disease model is amyloid hypothesis, tau protein, other conditions, vascular dementia being looped into it. Does that mean we actually have no idea where we are with Alzheimer's, or is there some truth still in these original hypotheses?
I think that many scientists would say that Alzheimer's is a multifactorial disease. So there could be a lot of reasons why dementia occurs. I think even the critics of the amyloid hypothesis, many of them would say amyloid proteins, tau proteins, as you mentioned, which is another protein that occurs inside the neurons in the brain, that they're connected with the disease. And these, of course, are the signature markings that the so-called discoverer of Alzheimer's disease, Alois Alzheimer's from Germany back more than 100 years ago, these were things that he noticed. And so I think it's clear that there's something going on there. What I think is less well understood is the relationship of that to other factors. And I think many scientists are now saying we need to look at possible infections. We need to look at inflammation in the brain that might be caused by a variety of sources. And we need to look at new thinking about repurposing certain drugs that might have proved effective for other disorders that might be more rapidly developed into something that could possibly be useful in Alzheimer's disease. So there's a lot of ideas out there, but I would not say throughout all the things we've learned. I have to say that it's been troubling to me that sometimes articles that I've written have been seized upon by people who I do not think are interested in developing our scientific institutions in a way that they are more effective, but are more interested in tearing them down, perhaps for political reasons, who have said, oh, well, because this research was false or misguided or falsified, that means that all Alzheimer's research, and maybe even by extension, all scientific research is completely untrustworthy. I don't believe that for a second. What I believe is that institutions need to be improved. They've fallen down on the job in certain ways. They've been complacent in certain ways. They've given in to their own weaknesses in certain ways, but we rely on them, and it's up to us to push them hard to do better for all of our benefit.
What's your take on the new political party coming in 2025? New NIH director, new HHS director. I mean, no one's confirmed yet, but as it stands, the nominations are put forth. Are you optimistic, pessimistic, or neutral in general for the future of healthcare as a whole?
Yeah, I would say that I'm pessimistic.
Okay.
I think some of the this is not an area that I've analyzed with great care, so I'm gonna speak only briefly about this. But I am skeptical about a lot of the ideas that are being put forth by some of the people who have been nominated for those positions. I think it would be a mistake to think that every idea they have is ridiculous. I don't take that position. Let's just talk for a second about RFK Jr. Look, I strongly disagree with almost everything he says about vaccines. And I think vaccines are one of the most important scientific developments of the last 100 years and have been instrumental in improving health outcomes globally. So I think it would be a terrible shame if ideas about, in my opinion, misguided ideas about the possible harm that vaccines might cause became the ascendant idea within our important health institutions. That said, he also suggests, and I think with good reason, that we need to be emphasizing eating better foods, eating foods that don't have so many additives, trying to emphasize healthful lifestyles. Those are things that I like to try to practice in my own life, and I subscribe to. And I think an injection of that into the body politic would be of great importance. So I guess what I would just say is that I hope that some of these appointees can be dissuaded by thoughtful people from some ideas that they might have that would be, I think, potentially disastrous to health systems and to the health of the public, and to emphasize others that could be of great benefit.
Yeah, I'm less concerned about the vaccines being at risk, because it feels like it's more of a state issue anyway than it is a federal issue. I do worry about some of the organizations like ACIP, the FDA Advisory Committee. But I'm hoping science will win at large here, because I feel when RFK Jr. says we need to prove vaccines are safe, it's like, can someone show him the data? Because that exists. I recently spoke with Dr. Paul Offit about the vaccine safety data net that we have, where there's a participating group of medical organizations that actually track vaccines once they're implemented. And that ends up being about 10% of all vaccines given. So if there's ever an issue, issues are caught fairly early because of that. And yet that's never talked about. And it seems like it's downplayed because people are trying to score political points and rise in the ranks. Disappointing, but I'm hoping ultimately that won't yield the negative things that we are all concerned about in the healthcare space.
Yeah, I couldn't agree with you more. And I wish that Paul Offit could maybe be made a close advisor in HHS. He'd be a great candidate for that, because he knows his stuff, and he's one of the true experts in the vaccine world that has done the most to promote the safe and effective use of vaccines.
What do you say to the average person that's listening and saying, oh man, I'm hearing of all this corruption with Alzheimer's research. How in the world can I possibly trust my doctor? How can I trust that the education my doctor received isn't based on flawed science?
Well, it's a great question, and there's no simple answer to that. But I think part of what I'm trying to do with the book that I wrote is to bring these sets of questions to a broad audience. And let me just say briefly that we're talking about a lot of scientific issues, and there are technical aspects to these, some of which are described in the book. But this is a book that is a narrative. It's a narrative investigation that tells the story of how these problems occurred by the story of people who are involved with these matters and their personal journeys. So I tried to make it accessible to people of, all kinds of people who might be interested in these for themselves, their families.
What do you hope that they get from reading the book?
One, I'd like there to be better public awareness and action on improving scientific institutions to shake them out of their complacency and lassitude in dealing with these very important issues of authenticity and correct scientific information in the science literature. And when I say how important that is, what I mean is that when the scientific literature is polluted with bad ideas, it skews thinking, it skews directions of research. And ultimately, as Matthew Schrag, who is an important character in my book and an incredibly principled scientist, has said, you can't cure a disease with fake science. Biology doesn't care. And so what we want is more rapid progress. So that, number one, is I hope that we can clean some things up and create an attitude of kind of thoughtful attention to this problem by the institutions of science, by scientists, and by the journals. So that's number one. Number two is I think people who are living with Alzheimer's, either as patients or as family members who are taking care of folks who have Alzheimer's, need a little bit of background in order to press for better action and better results in a field that has been very disappointing over the last 30 years. So let me give you an example that might be a direct answer to your question about what people say to their doctors. So a couple of new drugs have been approved recently for Alzheimer's dementia, and these are drugs that attack these amyloid proteins that we've been talking about. And the first one is called Leqembi. That's the one that's been on sale for more than a year now. And this is a drug that was regarded at the outset as what they call a blockbuster in the pharma industry, namely $1 billion a year or more in sales. Well, the uptake of this drug has been very, very slow. And the reason is, number one, the benefits of Leqembi are so small and so subtle that many doctors and scientists say that they're imperceptible to patients taking the drug or to their family members. So I'm not saying they do nothing. There's studies that have shown they do something, but the effects are very, very subtle and small.
So statistically significant, but perhaps not clinically.
There you go. Those are the terms I was reaching for. Thank you, Mike. So there's that, but also these drugs come with very serious risks of death or brain damage from brain swelling and bleeding. And of course, not every patient who takes it has those problems, but many do. And so it's a trade-off. Do you want to risk the possibility of dying for benefits that are so subtle as you say to be not clinically significant? And so the uptake of these drugs has been very slow. Only a few thousand people in this country so far, when it was thought that within a very short period of time, there would be a dramatic uptake, so large of an uptake that it could be the biggest cost for Medicare. But that just hasn't happened yet.
Has that not happened because the real world outcomes were not as good as the research outcomes? And if that's the case, why did that play out that way?
Well, we're really not sure yet of all the real world outcomes because there's such a slow uptake and there are so few people that...
Is it a cost prohibitive issue?
It's also a cost prohibitive issue, although now with Medicare paying for it, for most patients, it's much easier to afford. But for people who are living on fixed incomes, they're still having out-of-pocket costs of thousands and thousands of dollars a year for this drug. To pay for it outright without insurance would cost in the many tens of thousands a year when you include the necessary brain scans to check for safety issues associated with this. And of course, there's also the difficulty of taking the drugs, which is provided by infusions into your vein in a doctor's office. And this process has its own hazards. So I just want to say that this is a case where doctors are being asked by patients, should I take this drug? And I think many of them are saying, well, here are the costs and benefits of this. Here are the risks and benefits. And for a person in your condition, here are the things you and your family need to consider. And I think what we've seen by the uptake being so slow, it suggests that a lot of people are just deciding not to do it. I think based on thoughtful comments and advice by doctors. Now, some doctors won't prescribe this drug because they're that concerned about it, but many will. And I think even the ones that are prescribing it, many of them are saying, look, you have to weigh these for yourself. I can't tell you whether this is a good move for you or not. And really, a lot of things in medicine, probably you can say much better than I can, really come down to that. They come down to a judgment call that the doctor and the patient have to collaborate on.
Yeah, that's a term we use in the field called shared decision making, where a lot of times I think shared decision making should be implemented throughout every decision that we do in healthcare, but especially in areas where the evidence isn't quite so clear one way or the other. So a good example of this right now would probably be PSA testing or screening in otherwise healthy patients to potentially catch prostate cancer early. Before, in the past, we used to recommend it as a screening tool to catch prostate cancer early, and it was a higher level recommendation. Now it's moved back a bit to shared decision making, where we talk about the risks you face, the potential downstream effects, the risk that you face based on your family history, et cetera, and we come to the conclusion together whether or not to screen a healthy person. Not when someone already has symptoms. That's a diagnostic test at that point. So shared decision making is really important. And I'm curious how the shared decision-making component was so poorly predicted by the pharma industry in this case, where they thought it was going to be a blockbuster drug, especially in a case where when it comes to Alzheimer's disease, patients typically, what I've experienced, especially when a loved one has dementia, are almost desperate for anything. They're willing to reach for an experimental drug. They're willing to try anything because they're so desperate based on how devastating the condition is. If that's the case, knowing my knowledge of how the disease develops itself, how it impacts families, how is there such a poor prediction by the pharma industry with it not becoming a blockbuster drug? Where was the disconnect?
Yeah, I mean, I think I can't say for sure, but I think part of it is a pure financial equation. So these are publicly traded companies. They have shareholders, and they need to satisfy their shareholders. And so when you spend sometimes billions of dollars developing a drug, you need to have great expectations for how that drug's going to do,
Fair.
or you're not going to be able to do the research and to do the testing that's required. And so I think part of it is purely financial motive. A lot of this, look, the way we do drug development, it's a financial equation, and they're going to have to somehow justify their sunk costs.
Yeah. Do you have any issues with the current state of drug development as it exists today?
Well, I mean, I guess I would just say first of all, I'm not an expert in all drug development, but one thing that I've observed in working on this book is that there are some difficulties that FDA faces right now, contradictions that they face that I'm very sympathetic about. So on the one hand, particularly for diseases for which there are not good remedies, Alzheimer's among them, and for rare diseases, there is enormous pressure on the agency to fast track drugs, to wave them through, even though the results might be ambiguous, even though the results might be even not so great, because people who are in a desperate situation desperately want those drug approvals. And the agency is then blamed if they hold things up. What many people would say are perfectly understandable, scientifically sound thinking by their analysts. So what I feel very concerned about is that the pressure is sometimes going to result in drugs being approved that are not just not very effective, but could also be harmful, and the effects haven't been fully felt in the clinical trials that led up to their approval.
Is there a world where, and again, I don't consider myself an expert in this space, but I'm curious, based on your observations, if it would be valuable to create a new track for the FDA for medications where, there are exemptions made for people who have terminal illnesses, and they could be given an exemption to take a medicine where we know it's very dangerous, it's experimental, but because they have no other option, they may get an exemption to use a drug. Can there be some kind of research exemption track created for conditions like this?
I'm going to pass on this one.
Okay.
I just feel like it's a little outside my area of expertise.
Because I'm just trying to think from a rational standpoint of how to get around this issue that the FDA faces.
I do know there are already exemptions that the agency has the ability to grant exemptions. Companies have, I can't remember what the name of this expression is used for it, but they can give people drugs for, cases where they can't afford the drug, and there's a certain number of exemptions that they'll give for that.
Interesting.
Especially for rare diseases, but I don't know all the ins and outs of it.
When it comes to the FDA, we're talking about the medications of it all right now, but there's also the world of medical devices. And now that world is moving so rapidly, probably faster than ever before, with exponential rise in AI. You have all the interesting stuff Elon Musk is up to. What do you think the future of the FDA is when it comes to devices and approvals of experimental devices?
I think it's a tremendously exciting time. That I think there's a lot of potential there. And there's really, with AI, there's a lot of potential for new drug development as well. I think some of the claims being made are exaggerated because you still have to test drugs in people before they can be approved. And you
what's
can't have AI
an
do
exaggerated claim that you've heard?
Well, the idea that drug development is going to be sped up by many years for particular illnesses because of AI. I think there will be some advantages, and new ideas will come out of it that are tremendously important. So I do subscribe to that. But look, the most difficult hurdle for drug is always human testing, and that still has to happen. It has to happen in a safe and correct way to safeguard the public. So I would say that something that should be considered, and this might not be very popular with the current change of administration in Washington, is that right now company fees pay for FDA examination of their drugs or devices for approval. And the logic of this is that the companies need the approval, and consequently, they should subsidize the agency to do this examination. But in my opinion, and I think in the opinion of a lot of people who have studied this, this creates an inherent conflict of interest for the agency. The people who are essentially paying for their salaries are the ones who they are really wanting them to sign off on a particular drug. There's also the phenomenon that they call the revolving door, where people who are involved in the drug approval process in the federal government leave the agency, go to work for the drug companies that they were earlier passing judgment over, and now they're on the other side of it, earning 4 times their earlier salary. So that can be a powerful incentive as well. What I think that the federal government should do is fund those drug evaluations from tax dollars, because it's a much cleaner way that removes some of the conflicts of interest. And I know that they can't pay every FDA official the amount they could make at a drug company, but at least starting with being able to control that process fully and not depend on corporate fees, I think would be a good step.
For sure. Why, United States, we have the highest cost, the most money spent on healthcare, yet we don't have the greatest outcomes. Why do you think that's the case?
Well, I mean, I think... wow,
loaded question, right?
That is a big question.
Only on a podcast we can ask that, because normally on a TV segment, you'll have 3 minutes. It's like, go.
Well, I mean, again, this is not my direct area of expertise, but I think it's pretty abundantly clear that it's multifactorial. There's an entire gigantic mess with health insurance in our country. And there's a gigantic mess with drug pricing that the outgoing Biden administration has been attempting to make some progress on. And I don't know what the Trump administration is going to do when they come into power, but I sincerely hope that they continued to try to get deals together so that the American drug consumer is not subsidizing all this research in a way that really is done in no other country in the world. So those are 2 big things that I think need to be looked at carefully. In the health system that we have now, those are out of control costs. And this horribly tragic recent events associated with the murder of a drug insurance company executive in New York. I mean, this is terrible. And I think it's horrible that the social media associated with that subsequent to the murder, some people were kind of saying that the murderer was a hero as a result of it. I don't subscribe to that at all. I think it's a horrific thing to have done. That said, it shows the outpouring of frustration with the way in which medical insurance and drug company costs are really having a terrible, terrible effect on all of us. And so I think those are 2 areas that really need to be cleaned up.
Yeah. Even United Health was looking at, I believe it was a Department of Justice investigation for some kind of financial scheme going on. Similar vein as some of the people you were researching for the Alzheimer's work. What do you think should be the punishment or the outcome for someone who does participate in fraud, for someone who does make up scientific findings and is caught doing these things? Do you think this is simple as losing their job, discreditation? Should it be a criminal penalty?
I think all of those are possibilities. I think also sometimes, people deserve a second chance. I think it depends to some degree on the extent of the possible image manipulation, how long it went on, how seriously it might have damaged thinking in the field. Those are things that they can be hard to measure. But let me just give you an example from my own reporting. This guy at University of Southern California, who I mentioned, Zlakovich, there was evidence that he had been doctoring images in ways that had an effect on drug development, that had an effect on scientific thinking for many, many years. And ultimately, he wasn't able to stay in his job. He's been put on indefinite leave by the university. Now, or he's accepted indefinite leave. It's a little bit ambiguous how they characterize it.
Mm-hmm.
But the point is that it's very hard to recover from a pattern of misbehavior that goes back decades. It's very hard to support the idea that a person like that maybe made a mistake and should be allowed to learn from their mistake and improve their behavior. On the other hand, I'm very sympathetic to junior scientists and people who are drawn into either misconduct knowingly or maybe even unwittingly in some of these labs because they're beholden to powerful supervisors, professors whose future is dictated, who dictate the future of their young scientists within their lab. And so I think those people deserve a lot of sympathy and a lot of support. And I've talked to many of them, and it's sometimes heartbreaking, the stories you hear about how difficult it was for them, knowing that to talk to me could jeopardize their reputation and their career, even though they were kind of trapped in a training situation where they witnessed wrongdoing. But I'm thankful to say some of them stepped forward because they believe deeply in the integrity of science.
We talked about the peer review process improving. Do you think institutions like the major institutions of the world that are performing the scientific research should be also put on notice that they need to improve some things?
Yeah, I mean, I think really you have the institutions that regulate, fund, publish, and administer science. You've got universities, journals, regulatory agencies like the FDA, funders like the NIH, and foundations that fund important scientific research. They're all guilty of complacency. They're all guilty of not keeping up with the times, not keeping up with the reality that there are pervasive problems in image doctoring and related kinds of falsification of research. So I think taking it seriously is step one. Not just paying lip service, but really developing methods that are routinely applied in all of those institutions to be able to show the public that they care deeply about honest research that can be used to move the society forward, and not just drug development, but other forms of science forward. And so, yeah, I would say you got to hit those institutions hard. The institutional authorities of science are behind. They need to improve their game, get their game going on this.
Yeah, I think the incentive structure is a good place to start, because right now a lot of these institutions are heavily incentivized to just produce massive amounts of research, right or wrong, especially if almost like roulette, it lands on the right number. They can become incredibly wealthy as a result. You mentioned the advancement of science. You write for Science Magazine. Trust the science was a statement that was mentioned quite often over the last 5 years. People have lost trust in science. What do you think science means to the average person these days, and how can we improve that notion?
Yeah, I think one part of it is to move science out of this kind of realm of the great experts, the great brilliant people who are smarter than all the rest of us, and to remember that people can understand these ideas. Scientists, if anything, one of their the skills that they aren't the best at is communicating. And I think some of the great work being done is not well understood by the public. And so when they hear of scandals or difficulty in the field that is maybe slowing down progress, they tend to generalize that to things that maybe should be supported and that are actually very important. And so what I would say is these institutions need to stop feeling so proud of themselves and start thinking about how to convey important messages to the public. The second thing is sort of an interesting thing. I'm sure you're familiar with this as a doctor, is that it's been shown over and over that medical mistakes, of course, happen, but when one happens and the institution, like a hospital or a doctor who might be responsible for having made the mistake, cops to it and apologizes or explains it to the person who may have been victimized by that mistake, the response is
And
often,
hopefully institutes a new process to prevent the mistake from
there you
recurring.
go.
Yeah.
An important next step. But they've also found that people are able to accept that and respond in ways that, instead of going to endless litigation for malpractice, to, basically treat it like a human problem that we're all struggling to solve. And like you say, to get better, to improve. And so I think the institutions of science need to also be willing to say when mistakes were made, and even if they fear the reputational hit. One really great example has to do with universities. So universities are filled with every sort of human being. And when certain doctors, even famous people within the university, are found to have engaged in improper activity, misconduct of various kinds, sometimes what you see is universities investigate it, but in an endless way, in an endless, secretive way, where you don't really ever get to the bottom of it in a public way, so that the public is left wondering. This, I think, greatly diminishes trust in institutions. There should be a more public process. There should be a way of preserving the right of due process for people who are accused of wrongdoing, the right of due diligence on the part of the organization to look at things carefully, but also balance that with the need to provide the public with a real explanation for why they should trust the institution. And that's why, in my opinion, some of the problems have to do with independence, the independence of examination of these problems. So when you have a serious set of accusations, for example, in the doctoring of research, it's almost always kicked back to the university, who then secretly look into it for months, sometimes for years. Public never learns of what the result was. That's a terrible way to go about it, because you've placed the institution that has the most to lose and the least to gain from a robust, rapid public examination of an important issue that the society and their community has a right to know about. You put them in charge of it, and then what do you get? You get more generalized distrust. So when you have people, particularly nowadays, who are generally distrustful of public health officials, scientists, public institutions like research institutions and regulatory agencies, and decrying all of their flaws and mistakes, I think often what you have is a symptom of a lack of transparency. When a guy like me has to be the one exposing problems that could have been detected for years and years by responsible institutions, you have a problem right off the bat.
Yeah, I'm glad you said the word transparency, because the whole time you were discussing that, that's what I'm craving for. And I think, honestly, if we go back to the pandemic, the issue that I think all the organizations, CDC, FDA, all of them messed up with was the lack of transparency and honesty when it came to what we know and what we don't know, and at times overpromising things in order to get better buy-in. And I feel like that ultimately ended up harming people, because that distrust, maybe you got better buy-in initially, but long-term, if you hurt that trust, as most of us know through human relationships, whether it's a friend, loved one, boyfriend, girlfriend, husband, wife, losing trust is really hard to get back. So while yes, you may have an initial better outcome, long-term, you're creating a bigger problem. And I feel like these organizations that say, oh, well, I'd rather put out a more clear message rather than a garbled message. Like right now with the COVID boosters as an example, Dr. Paul Offit and I talked about this, where most countries across the globe say that the COVID booster is really solid for people who are at higher risk, those over the age of 65, perhaps immunocompromised states, et cetera. And the United States says, no, we're going to say it's good for everyone. And the real reason why the people in charge say that is because they say when you send a nuanced message, we feel like there's less uptake. And there's no real harm of people getting it that are lower risk. And while that could be true, you're not really telling the complete picture. And I feel like people have good BS meters. And if they sense that they're being misled, almost like the opposite of what you described when you lean in and say, we did mess up. Here's what we did wrong. Here's what we're going to do better. This is the opposite of that. It's almost like you're being lied to directly to your face. How do you then build trust in that organization? Do you feel that?
Yeah, I couldn't agree with you more. Really, there has to be better honesty and transparency by institutions. And there's so much fear within those institutions if they show any weakness or admit any weakness that they'll be sued or they'll have other public relations problems. Let me just say, though, that even though I just wrote a book about really a big set of problems
yeah, that's funny.
in Alzheimer's disease, yeah. I do feel hopeful in certain ways, and I wanted to describe a couple of those. We live in an incredibly exciting time in the sense that it's much easier now for problems to be caught because of the ability to crowdsource those problems. So what you see is that when institutions like universities and journals and government agencies have dropped the ball on image falsification in Alzheimer's and in other fields, you've seen this sort of army of volunteer image sleuths, and you've seen the rise of important whistleblowers to point out these problems and to force institutions to take notice. This has been a very, very important and large development that I think ultimately is going to greatly benefit patients. It's certainly going to change the nature of research in Alzheimer's disease. It's already having that effect. And consequently, it's going to create openings for new thinking. And there are people waiting in the wings to try to get support for new ideas and new approaches to studying these problems that will benefit from the sort of emergence of crowdsourcing and volunteers who are able to do things that institutions can't always do because of the constraints that they feel legally or in other ways.
Yeah. It is optimistic. And at the same time, I'm currently reading a book called The Death of Expertise. Have you heard of it?
Yeah, I've heard of it. I haven't read it.
That leads me to be a bit more pessimistic because they described the phenomenon that I can relate to from the social media world that I exist in, where before in the past, many years ago, it was people didn't know as much science. Then it went to people were willfully ignorant. They didn't care to learn much about science, even though it was available to them. And now it's at a place where it's like, you're not just wrong, you're aggressively wrong and loud about it. And the louder you are, the better you can do on some of these social media platforms. And I worry how ultimately that plays out because the scientific community is at a significant disadvantage due to their lack of competency in communication is a nice way to put it. Whereas those people who are aggressively wrong are so captivating, are so watchable, are the ones that the algorithms end up pushing. So I ultimately don't know how this plays out long term.
Yeah, I couldn't agree more on that. It's kind of terrifying in that way. I guess I would just have to hold out the possibility that these institutions can get better at what they do, not just in administering and reviewing the science, but also in understanding how to use media in a way that effectively reaches people. And, I would just say that that your example of someone who, your rather substantial side gig from being a doctor is, it's a good sign that we have to have people who can do more than one thing and can kind of encourage this dialogue. But yes, we're in a big hole in that way, and I certainly don't have a solution for it. But what I'm trying to do is to put accessible information out into the world that can help move people in a good direction, that can help raise awareness of these issues, but also force institutions to sit up and take notice and to make themselves better. What's said on social media is one thing. What institutions do is another. They're not completely separate from each other, but these institutions are powerful and they can do much better. I want to say that, I work for Science Magazine. I think one thing that I've appreciated there is that even though they themselves have been caught many times in having published studies that then later are shown to have been flawed or untrue, maybe even falsified. They're quite determined to put out accurate information, to do it in a way that faces down hard issues in science and medicine. Otherwise, I wouldn't be writing the stuff that I'm writing. They're willing to take a good hard look at it. And I think that's the sort of thing that I think a lot of the institutions haven't been willing to do, is to take a good hard look in the mirror and say, what am I doing that's leading to my own problems? How can I get better at this? And
they want to look outside for why their problems are happening.
That's exactly right. Yeah. And it's not that they are the sole cause of all their own problems, but they need to clean up their own house.
Yeah. What's one positive thing we can leave viewers and listeners with when it comes to the future of Alzheimer's research? Where do you think we go in the next 20 years?
Well, I think one thing that I'm really looking forward to is some interesting research in two realms. One is the possible benefits of the new GLP-1 inhibitors. So these are the drugs like Ozempic and others that have been taken for weight loss that, wow, amazing possible effects in other realms, including the possibility of attacking dementia associated with different causes of dementia, including Alzheimer's. So I'm looking forward to seeing whether that might potentially have some benefit. I'm also very curious about results from clinical trials coming up associated with the possibility that infections play a role in Alzheimer's disease. Even finding evidence of multifactorial reasons for the disease, meaning more than one reason. Perhaps amyloid proteins play a role, perhaps infections play a role, perhaps other ways in which inflammation in the brain can play a role. I think scientists who are looking at these various components and trying to understand how we can attack more than one thing at a time are likely to gain ascendancy in coming years. So to me, there's no quick fix on this. We unfortunately are way behind, and I think because of the undue extreme emphasis on one way of thinking in the field, some things have been left by the wayside for many years that deserve a closer look. I think those things ultimately will get that closer look. And because there's so many scientists who have a lot of integrity in this field, I think we're going to see some results in years to come, but I can't make any prediction of how soon.
Yeah. I think it's equally exciting to me as it is a bit scary to know that a potential virus you're exposed to when you're younger or even as an adult can potentially play a role. It's something that impacts you in your 70s and 80s without you even realizing it. So on one side, very interesting. On the other side, oh man, so many unknowns, so many variables.
Yeah. So many unknowns, so many variables. And it can be a scary thing, but I think also being courageous enough to look hard at ideas that might be controversial is one part of it. It's one part of it.
For sure. Well, thank you so much for your work. Excited for our listeners and readers to check it out. Where can people follow along your journalistic work?
Well, of course, they can look me up on the Science Magazine website. My page is easily findable up there with all my stories. And of course, I'd be very grateful for people to get a look at my book, which is available from all the online resellers and from your local bookstore. Awesome. We like to support.
Thank you so much.
Okay, thank you, Mike.
Did you know about the eyeball licking trend from Japan? Click here to learn more about that. There's more than meets the eye in that video. As always, stay happy and healthy.